And welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. We're delighted to have you, and we're starting things out with some 24-hour videos here from the SDO and 171 angstroms. And if you're wondering about the origins of these videos, they are because there is a lot of crap, a lot of nonsense, garbage, junk pseudoscience, a bunch of crap about space weather on YouTube. We saw a niche, and rather than complain about it not being filled, we decided to fill it instead. Let's go around the horn here, as we've got a new sunspot rising in the northeast. So we're going to start out right there. And it's a pretty minor sunspot group at the moment. There are a lot of filaments on the Earth-facing portion of the solar disk. We've grown a few additional filaments since yesterday, a little uptick in the X-ray flux, and indeed in the 10.7 centimeter radial flux, which we'll get to here. Here is the northwestern limb. We may have a coronal mass ejection impact late in the day tomorrow, early in the day on May 2nd. We'll show you some modeling of that a little bit later in the video. Here is your western equatorial region. You can see some plasma reorientations happening there south of center disk. This should give you a little better view of that. And we do have some magnetically complex and indeed large sunspots. The likelihood of solar flares remains quite high. Here's the southeastern limb, little crown prominence hanging out down there in the south-southeastern portion. And thanks for leaving a comment, TinMan1057. All right, so let's get to some more data sets here. Next thing we'll look at, and thanks for leaving a comment, Mr. Bordages as well. Next thing we'll look at is sunspots. Again, we've got indeed quite a large group here approaching the southwestern limb. Also, this group up in the north has degraded a little bit. Besides that, fairly stable. And as this group approaches the west, don't be surprised to see it produce an M or even an X-class flare. Here is your colorized magnetogram. These SDO browse data videos are yesterday plus today. So that's April 29th plus April 30th to date. And let's take a brief look at what's going on Crescent Earth. Check it out. Here's a part of the aftermath of that crazy eruption at Shivaluch. Base camp was destroyed here by pyroclastic flows and thick tephra deposits there, mixing with melting snow and sunlight, creating a thick mud. You can see there up to window level on those trailers. And that pyroclastic flow reached as far as about 2 kilometers with a deposit thickness of about 10 centimeters. Not sure if Shivaluch is currently erupting. It's not on the list. Abico is erupting, though, producing a 10,000-foot plume of volcanic ash. It's a flight level 100, flight level 150 over Semeru on East Java, Indonesia. Popocatépetl also exploding, flight level 190. It's a 19,000-foot ash plume over central Mexico. Fuego exploding in Guatemala, flight level 150. Cotopaxi exploding in Ecuador, flight level 210, and flight level 220 over Sabancaya in Peru. It's a 22,000-foot plume of volcanic ash. Please do not pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. As far as seismicity for the past 24 hours, no major quakes here, it looks like. And let's check the list. There was a 4.5 at California, which we will cite here in a moment, but barely any quakes over a 5 magnitude. So it's been pretty calm, no major quakes, quite a few quakes, but none of a large magnitude. So be prepared for the possibility that some of these quakes could be foreshocks. One of the only 5+ magnitude quakes was this 5.1 at Indonesia. That 5.1 came in at 22:37 Universal Time yesterday evening. Looks like only one quake of a 5+ magnitude. There was a 4.5 at California, though, so just a quick reminder that any earthquake can be a foreshock. And we may be seeing some of those play out now, and let's get back to space, as there's plenty going on. Here's the past 24 hours of... We've gone back to 171 angstroms here, and we've added 211 angstroms. So you'll see a lot of features here, coronal holes. You'll see some plasma reorganizing itself in the southern hemisphere down there. Some coronal mass ejections actually going on. You can also see active regions in the extended corona with these wavelengths. Let's change out the 211 angstroms for 131. These wavelengths are fantastic at showing plasma orienting to magnetic fields. As you can see, a lot of potential field surface source lines there terminating at active regions. That's no coincidence. And the 10.7 centimeter radial flux is now at 156 solar flux units. So we just broke through one of the support levels here. That was around 155 solar flux units. You can see this sort of support level for the radial flux right here around the mid 150s. You can see a lot of peaks in this area right here. So it could be time for a breakout to happen here. 155 solar flux units is somewhat of a support level there for the 10.7 centimeter radial flux depicted by this black line. The red line is a sunspot number, and let's move on to NOAA's Space Weather Enthusiast dashboard. We are seeing the coronal hole high-speed stream subsiding here. So this is coming to a close, the coronal hole high-speed stream. It reached as high as over 700 kilometers per second. And NOAA's not forecasting any geomagnetic unrest until late in the day on May 2nd. Not exactly sure what it's from, as it does not include any sort of an explanation of that. Let's check their Enlil spiral to see if that gives us a little more info. So there's NOAA's Enlil spiral, and no indication of why a KP4 is forecast. Next, let's move to the Integrated Space Weather Analysis Center, and you can see NASA, like us, forecasted a CME impact by late day tomorrow. So the alert should start around midday tomorrow on May 1st and extending to about midday on May 2nd. It should be a fairly minor impact. We don't expect to see it get higher than a KP6, as it is a glancing blow expected to mostly miss Earth to the south, as you can see on this middle pane here. That is just this pane turned 90 degrees. You can see here you're looking at east and west. Here you're looking at north and south on your vertical axis. NOAA not agreeing, but NASA is agreeing with our forecast that there might be a glancing blow here. A minor CME impact coming late in the day tomorrow on May 1st. We doubt we'll see the aurora at mid-latitudes from this. Continuing on to look at some more data here, the past 4 hours of Earth's magnetic moment from space. The space weather modeling framework here is modeling magnetohydrodynamic pressure. Things are geomagnetically calm as the Earth system endeavors to reach static equilibrium. Like basically everything in nature. Anyway, that's the past 4 hours Earth's magnetic moment from space here, looking pretty calm. Earth's magnetic moment from the ground depicted here. This will show you the most likely places to see things like telluric currents, power line, railway, pipeline induction. Also, the most likely places to see the aurora. And again, you're pretty unlikely to be seeing the aurora here at the moment. For the past 4 hours, things quite geomagnetically calm. It is a KP 1.66 situation. And for those of you unfamiliar with the planetary K index, it's an average of global geomagnetism. So sub KP2, and let's take a look at the real-time solar wind next. By the way, that is measured outside of Earth's magnetosphere over here at Lagrangian point 1, about 1 million miles toward the sun. Next time you're hanging out at noontime, realize that there are some spacecraft about 1 million miles toward the sun. Like the ACE and Discover, at the moment, only the ACE is providing data here. Current conditions are just dropping below 500 kilometers per second there in the 490s. 495 kilometers per second for the solar wind speed. Solar wind density here, very diffuse. Less than 1 proton per cubic centimeter at 0.64 protons per cubic centimeter. And if you want to compare that to the amount of protons per cubic centimeter around the sea level of the planet Earth, it's something like 6 quadrillion protons per cubic centimeter. Again, because these are measured in space, where it's not a complete vacuum. However, it is very diffuse gas. It's not what you'd call breathable. Next, we'll move on to the magnetic data. There are your GOES magnetometers, the GOES 16 and GOES 18s. Geosynchronous near equatorial flights there, measuring the magnetic field within the Earth system. We're continuing to see kind of high lows and low highs, a tighter range for the GOES magnetometers. And next we'll look at the heliospheric current sheet, and Earth is just about to switch into a North Pole current sheet. So you can see that North Pole current sheet speeding this way. And well before tomorrow's space weather video, Earth will be in a North Pole-oriented current sheet depicted there in green. Sector boundary crossing coming in just a few hours. Probably something like 6 or 8 hours there. And let's take a look at the line of sight field plot next. This ground-based National Solar Observatory data is super important. It tells us a lot about what's going on. It even has predictive value, believe it or not. Yes, our videos, they have predictive value, unlike some channels that consider themselves competition to us, which have laugh value and not much else. Here's our line of sight coronal hole plot, and we've got North Pole oriented coronal holes here rotating in on a large portion of the solar disk. So if you look at the latest image, you can see several North Pole oriented coronal holes there. Let's take a look at our SDO imagery. So quite well defined coronal holes here rotating in of North Pole orientation. The sector boundary crossing is right about here. These are south. These are north. And we can expect to see those become geo-effective in less than a week. Which brings us to sunspots. We do have one small new sunspot group. It just rose over here. It'll be known as 3293, right up here in the northeast. At the moment, it's only alpha class. Let's see if we can figure out anything else about that. We'll show you a high-res close-up toward the end of the video. This is a 24-hour video from the SDO continuum. And there is a closer view of the photosphere. So degradation of this sunspot group up here. We've got, well, this might actually be known as 3293 right over here. So there's a new sunspot that just formed there. So that is 3293 probably. This will probably be 3294 up here. So again, likely having two new named sunspot groups. And again, all eyes on this group down here. As it approaches the western limb, it becomes more and more likely to produce a large flare. Let's talk energetic particles and solar flares. No spikes in the proton flux. Those would be known as SEPs, or solar energetic particle events. They've been calm for a long time here, over a week. The GOES X-ray flux here only featuring C-class intensifications, although the background X-ray flux did rise into the background sea level as forecast. Largest flare of the past 24 came in just a few hours ago here. It was a C7.2 peak flux was just before 9 o'clock this morning on April 30th. Let's take a look at some of our favorite wavelengths to view flares. There is your 94 angstroms wavelength. There is a possibility to see a large flare from this group up here. Again, there may be some umbrae up there that we're not witnessing yet. But at the moment, when we did show prep, it was only an alpha class sunspot group. Let's switch to 131 angstroms. By the way, alpha class means only one umbral polarity. In this case, probably North Pole oriented. And our regular viewers are probably well aware that the most likely large flare players would be associated with the sunspots. Seems pretty obvious. And let's get back to some more data here, and let's take a step back to invite you to join us over on Twitter. Yeah, over on Twitter. Thanks to our new followers over on Twitter. Of course, censorship continues over there. And by the way, we've started an Amazon shop. So since we need to be able to endorse certain products, we have to get paid for it. So we have created a new Amazon shop. If you haven't checked it out, head over to our Twitter feed, twitter.com/smashomash. I've just pinned that Amazon shop there. We've only got 2 lists at the moment. Check it out. We've got coffee and supplements. And here's what's going on over our head in Lehigh Valley. So we always like to orient our viewers before we talk about coronal mass ejections and filaments and so on. So here's the current situation. Mercury and the sun very close together in the sky. And if you are looking at the sky after dusk, you might see the third brightest object up there, Venus. That's the current situation. And let's take a look at a solar system forecast next. We've got terrestrial planets versus gas giants. Divided here. The divided solar system. Terrestrial planets on our side, gas giants on the other side. Here is your 1-week solar system forecast. Here's where things will be on May 7th. Right around full moon time there. And next we'll move to coronagraphs. So here are George Mason University's coronagraphs from yesterday. You can see some CMEs happening there indeed. Are they earthly directed? The answer is, we don't think so. Here are today's coronagraphs, an additional 46 frames. And let's show the Soho-Lasco C2 and C3 here on the Space Weather Prediction Center before we show some additional custom coronagraphs. I don't see any halos from those. I don't suspect they are earthly directed. Here is the view from Stereo A and the Soho-Lasco C3. And we have frozen the frame here at 906 for the Soho-Lasco C3 on the right and 909. So here's another great example of a CME structure. Coronal mass ejection. Now in this case, you've got a very dense outer portion, and the core here looks empty. So in this situation, let's say that this struck the Earth while moving in this sort of a direction, right? What would happen here is you would see a very strong CME impact, and then you would see a lull in the activity as this hollow core passes through, and then an even stronger trailing edge. So again, we don't expect that to be earthly directed. Let me bring this back a little bit. Keep in mind these are not synced. Great example of a CME there on both Stereo A. and on the Soho Lasco. We're going to get the filaments here in a minute. First, our custom Helio Viewer 24-hour videos. Sweet coronagraphs, as you may have come to expect from the channel. Let's get a little bit closer here. Great view of 193 angstroms from SDO, along with those coronagraphs. So that's the current state of affairs. Again, we'll get to filaments next. And there are a lot of filaments, as depicted here from the El Teide, Spain's ground-based hydrogen alpha imagery. You can see filaments hanging off the edge here, showing up as bright features known as prominences. And you can see filaments actually absorbing light in these areas, like the Remco Evenpol filament, which is right there. And just a reminder, we've been naming filaments after living people. If you want to name a filament, join us over on Twitter. Follow the hashtag #NameThatFilament. And if you ain't got a Twitter, why not create one? And if you've unplugged entirely from social media, we certainly don't blame you. It is truly pathetic, especially since 2020, as if it wasn't sickening enough, starting by about 2016, which coincidentally is the same year that the U.S. became a banana republic. Yeah, the free press was dead by the year 2016. We think it happened in 2015, but anyway, that's the filament situation. The likelihood of coronal mass ejections remains very, very high. Remember, folks, you don't need solar flares or even sunspots to see a coronal mass ejection. We covered plenty of them, and we learned how to forecast coronal mass ejections around solar minimum. Next, we've got the last couple of hours here from the GOES 16 SUVI. We can see a crown prominence there forming around the North Polar region. And when we actually get to solar maximum, it's going to be exciting. It's going to be even more exciting than the current activity that we've been seeing. So that's the past couple of hours. How about the past day? And there we're back to where we started there. Our 171 angstroms wavelength. All right, so there's the past couple of hours, and this brings us to our bonus features segment, starting out with satellite charging hazards. We've got some internal charging hazards here all the way from the west coast of Africa into the central Pacific. So those are internal charging hazards, minor internal charging hazards caused by high energy electrons getting inside of spacecraft. So if you want to follow that yourself, that's the satellite's community dashboard. It gives us insight into the physics of how things are flowing around in the Earth system. Next, the electron flux. This is measured at the F layer of the ionosphere using radiography by the GOES 16 and GOES 18 from their near equatorial geosynchronous orbits at about 23,500 miles of altitude. And we reached about 12 times. I think we were pushing 13 times warning levels yesterday with the electron flux. Those are the electrons of the greater than or equal to 2 mega electron volts. Here's the forecast model. We never reached the high levels that NOAA forecasted, although NOAA is forecasting a continued increase. No arguments from me there. The green boxes are the forecast. The yellow diamonds are the observation. And there's the one-year graph to put the relativistic electrons in context. Once again, those are measured at the F layer of the ionosphere. Feel free to pause the video on this frame, if you're not familiar with the penetration of electromagnetic radiation, thermosphere temperatures, and chemical concentrations. Here is the F layer in its vibrational frequency glory. So the story of the day continues to be low-frequency anomalies. The ionosphere is still puffed up, but not nearly as puffed up as it was around the end of that major geomagnetic storm we had, where we saw an extended periods of KP8. Ionosphere here looking a little bit anomalously. And if you're not familiar with the raw vibrational frequency, here is the anomalygram. You can see here most of the low frequency anomalies occurring in the southern hemisphere, so a bit of a disparity. As the ionosphere, like the rest of the Earth system, is attempting to reach static equilibrium. You can see a lot more blue on the map here, depicting high frequency anomalies. As the ionosphere slowly subsides from an extreme input from a coronal mass ejection impact. All right, so here's the latest image. That's 12:45 Universal Time ionogram and 12:45 Universal Time anomalygram. Pardon our lateness. We are coming a little bit late today. After all, it is the Sunday edition. Next, we'll show the total electron content. Feel free to pause the video on this frame if you're not familiar with the distances to things in miles, the distances to things like the SDO, or perhaps the inner Van Allen belt. Here's your total electron content forecast, depicting the free electrons to about 12,500 miles of altitude. So nothing to write home about here. This is pretty normal. And those red areas are places where you can expect GPS errors of thousands of miles, perhaps. We will close out the space weather portion of this video and shift gears to meteorology right after we show the high-res imagery. So here is your high-res SDO intensitygram. And here's your high-res SDO magnetogram. What the hell? Why is it not drawing? There we go. I don't know what's up with that, but here's this new sunspot group, and it looks like we may have additional umbrae there. In fact, that might be two sunspot groups rising. That looks like two sunspot groups. So the second one looks much larger in terms of the magnetic fields, and there you can see them. The leading group, that's the farther north one. That is a North Pole-oriented alpha class sunspot. This one down here might also be alpha class. At the moment, we only see one umbra. But we'll have at least three new name sunspot groups today. This one down here, most likely, also two up here. So there's your full disk rockback. We have a new active region forming here as well. At the moment, no umbrae. And let's blast through meteorology. What we're currently looking at here is mean sea level pressure. And we've got the eastern portion of the U.S. there, the part of the U.S. east of the Mississippi there, dominated by high pressure. And here's a great example to show you the difference between low and high pressure. So you can see low pressure here, all the lines are pointing toward it. That's because low pressure sucks and high pressure blows. So here you can see lines emanating out as it rotates clockwise. A high pressure system is a pressing down on the atmosphere, and a low pressure system is a lifting up. The lifting up causes air to rush toward that area, and the pressing down causes air to rush away from that area. That's a basic atmospheric physics concept. And there's a strong low here south of Australia as well. Let's break down the jet streams. And these are the jet streams of the eastern world. Surface winds are depicted here. Surface winds of the west, now animated right here. These are the jet streams of this side of the planet. Jet streams of Europe, Africa, and the Middle East shown here. And don't forget the surface winds. There you have it. All right, we'll blast through the rest of our meteorology segment here. Here is clouds and fog over the Americas. Shout out to our viewers from all around the planet, like Bruce Minas of Brazil, a.k.a. the Batman. And that's what's going on in terms of clouds and fog. Here's our weather.gov map, and we've got some windy conditions indeed on the east coast of the U.S., also Florida, featuring some severe weather warnings, including tornado warnings coming in this morning. Pay attention to that. Weather.gov is the location to check out. If your location's lit, head to weather.gov and click it. Those are too many counties for us to cover. However, we'll show you some forecasts. Here's pressure and precipitation, as this low pressure is just going to be hanging around Lake Huron area. It's just going to be loitering there. And that's going to bring wave after wave of moisture to the eastern Great Lakes region. That's your 72-hour GFS pressure and precipitation forecast. We've also got your GFS positive accumulated snow depth change in inches forecast, and there's some significant snow continuing here into the month of May for both Pennsylvania, Wisconsin, Michigan, California, Indiana, Ohio, West Virginia. Also Minnesota and Colorado making a list of states to receive snow. That's your 72-hour GFS positive accumulated snow depth change forecast in inches. And let's take a look at the difference between the Euro and the GFS model. So there is snow accumulation for the next 3 days on the Euro model. And there it is on the GFS model, quite similar. Snow continues into the month of May. Apparently the planet is so hot that it's cold. Next, we've got your lightning mapper. Strong lightning there going across Florida and into the southwestern Atlantic. Also up the east coast. We'll show a real-time lightning map next from lightningmaps.org. And do we have any terrestrial strikes in the U.S.? That is a question to ask yourself, and the answer is no. But there's quite a lot of lightning off the east coast. Perhaps some great surf there happening at the Outer Banks. Anyway, very strong lightning there off the east coast of the U.S. at the moment. And let's also cover clouds and fog, U.S. Doppler radar, and water vapor. So there's the full U.S. Doppler radar view. Here's a lower 48 view. Again, that low pressure around Lake Huron is going to hang out for days and bring multiple waves of moisture. Here is clouds and fog depicted by 3.9 micrometer radiation, part of the infrared spectrum. And here is 6.19 micrometer radiation, a different part of the infrared spectrum, showing the water vapor. It looks like it's clear skies over southern Texas. And we hope it's clear skies for you as well if you are planning outdoor activities. If you're a cyclist, we're hoping for dry roads. Anyway, here's your recap, starting with the U.S. Doppler radar. Clouds and fog for the lower 48. And there is the water vapor map. By the way, if you enjoy the content, please support the Smash News Network, least busted name in news. We are paid just this side of nothing to put the content on YouTube or any place else. One of the ways that you can help out the channel is by picking up our merch. Now, this one is directed directly at Ben Davidson. Ben Davidson, a cosmology invalid. He is a complete ignoramus when it comes to cosmology, and he's invented this thing called the galactic current sheet, which he claims through some sort of magical process is going to mysteriously cause the sun to explode, which is going to mysteriously cause Earth's axis to rapidly shift, and so on. It's because Ben does not understand cosmology, astrophysics, electricity, magnetism, etc. He basically doesn't seem to understand physics at all. And it's pretty sad. So this is a direct affront to Ben Davidson's nonsense. It is a direct insult because Ben Davidson is an imbecile. And for some reason, he's convinced a lot of people, I guess by sounding confident, the galactic current sheet, a non-existent structure that a lot of people are currently building bunkers to avoid. You can find links below the video to the Redbubble shop as well as on the homepage at smashomash.com. If you want to support the channel via subscription services, consider becoming a member of the Smash team at smashomash.com/smash team. We've got a gold and a silver level. Those are paid. There's also a bronze level, which will cost you $0 per month. We send out email alerts. We even provide at smashomash.com email addresses for those at the gold level who prefer their own custom email address. So help out the channel that way. We launched our custom subscription services site back in October of 2021 because we needed superior capabilities to Patreon. You can also help out the channel by checking out the Hemp Lucid shop. If you're shopping on Hemp Lucid, don't forget to enter the promo code SMASHOMASH to save some dough on checkout. Today's featured product on Hemp Lucid is the full spectrum CBD body balm in cedarwood. So this will give you a great tingling sensation. You might feel like a feeling of warmth when you apply this. I like it. It smells great. So perhaps check that out. Lots of other products available today. I just figured I'd show you one of the ones that Hemp Lucid was kind enough to send us as a sample for our endorsement. And it is highly endorsed. The full spectrum CBD body balm in cedarwood. So if you're unwilling or unable to open your cobweb encrusted wallet and help us out with picking up merch or becoming a member of the Smash team or donating on PayPal, well, help us out with clicks. Come join us on Instagram if you're interested in things like lifestyle and fitness posts. If you need to be motivated to go ride your bike, we will help you out on Instagram. Anyway, thanks to everybody for tuning in to the Daily Space Weather. For all of those who think there is any competition to these videos, we laugh and laugh. So anyway, once again, thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And may that solar wind be at your back.